purpose of this video is for you, when given an equation, to know what type of reaction it is. With anything, the main question is what's the pattern, what's the criteria, basically, when you identify something. Now you're going to be separating things into categories. And this is just to model what you're thinking is going to look like. Dr. Square always puts any object or thing into three categories. Is it a friend, a foe, or does he not know? Now, so the Eye of Sauron, not the Eye of Sauron, Sauron, the wizard who created the ring, that would definitely go in the foe category. Whereas this guy would definitely go in the unknown, because Dr. Square doesn't know. Who is he? And this cat would go in the friend category. Now with those three, it's obvious what the criteria is, because it's Dr. Square's feelings towards the person. But with equations, it might get a little more hard to see, but before we get there, I want to review some terms. Hydrocarbon, something that looks like this, all right? Carbon and hydrogen in the molecule predominantly. The reactants of the chemicals before the chemical changes, the products are the after the chemical changes. These are my products, excuse me, these are my reactants, these are my products. And the chemical equation's general form is that the reactants are on the left, the products are on the right. Now, to explain the analogy, you've got these two scenarios, Dr. Square and the reactions. Now, the categories are, for Dr. Square, it's friend, foe, or unknown, and for an reaction, or an equation, it's these 5 different categories. And the criteria, the traits of the object. What is Dr. Square's feeling about the object? Whereas with reactions or equations, you're mainly going to focus in on what the products are and what the reactants are. All right, here's just a visual to show you. You're given an equation, and you're given this equation, and you basically want to fit it into one of these categories. What is it? All right, and you're mainly going to look at either the reactants or the products to know what it is. I'm going to go over a bunch of examples. All right, here we go. This one. Now, if I look, I've got one thing breaking down into 2 things. So that looks kind of like this. One thing breaking down into 2 things. That's decomposition. Now here, if you notice right here, this is a hydrocarbon, and I'm combining it with oxygen to make these 2 things. So that is combustion. Now I've got 2 things making 1. So this is synthesis. Here I've got 2, these are like 2 compounds where the compounds parts all swap places. A visual for this is this. All right, so you can see that the Na swaps place with the hydrogen, and this chlorine swap places with the sulfate, and that's why this would be a double displacement reaction. Here's another one where something's swapping places. Here I've got the iron taking the place of the copper, and that kind of looks like this. I've got the iron is the red circle, the copper is the purple, I believe. I'm not sure what the actual picture is going to be here, and the nitrate is the blue square. There you go. So this is single displacement. Here, once again, I've got oxygen gas, and I'm making carbon dioxide and water, so this is combustion, because butane, even though this isn't butane, but it's a hydrocarbon, it has the same elements making it up. That's what makes this a combustion reaction. Now, once again, I have two compounds, 1, 2, and they make two new compounds. So this kind of looks like this. AB plus CD equals AD and CD. Because if you look, the front part of the first compound and the front part of the second compound kind of swap spots. And that's what makes this a double displacement reaction. Now, this is another one that we've seen before. This is a single displacement because you've got an element and a compound, and the element takes the spot of another element, where the zinc takes the spot of the copper. Here, two compounds making two new compounds makes this double displacement. Here, I've got two elements, A and B, forming AB. That's what makes this a synthesis reaction. Now, I've got one compound, potassium chlorate. It's making two simpler compounds, potassium chloride and oxygen gas, and that's what makes this a decomposition reaction. Now, I've got one element, a compound, or A, forming into A, or with BC, and BC, the C part is the nitrate, and that forms ACB, where you can see the silver gets on its own, and the copper combines with the nitrate. That's what makes this a single displacement reaction. And that's it.